Hey, in this tutorial we're looking at section 10.4, which is on volumes. Hey, so for this one, hey, if we have two functions, g of x and f of x, where g of x is bigger than f of x, hey, over the interval from a to b, right, and the area between them is rotated about the x-axis, then we get a volume of revolution as we'd expect. However, our volume will have a hole in it. Okay, so if we have a look at this little picture here, so we've got our g of x, okay, which is on top, okay, so it's bigger than our f of x, okay, so we've got our area in between them, okay, from A to B, okay, which we've just happened to make our intercepts. Okay, if we rotate that around, okay, this part would come around and then go back in, so we would end up with a volume going around, but we'd have this whole bit in the middle that would be empty. Okay, so this volume is found very similarly like we did in the last video, okay, where we would have just had our volume equals pi times the integral from a to b of g of x squared. Well, this time it's the volume of pi times, so the volume equals pi times the integral from a to b of g of x squared minus f of x squared dx. Okay, similarly, okay, if we're going to rotate around our y-axis, okay, our formula is given by v equals pi times the integral from a to b of g of y squared minus f of y squared. The main thing to remember here, okay, is again that we say g of y is bigger than f of y, but what that means is g of y, okay, is further from our y-axis. Okay, just like our g of x was further from our x-axis, okay, and f of x is closer to our x-axis. G of y is further from our y-axis and f of y is closer to our y-axis. Okay. But essentially, that's all we've got in terms of theory for this, so we'll have a look at our couple of worked examples for this section. So worked example 8 is find the volume formed when the area bounded by the curve y equals 4 minus x squared and the line y equals 3 is rotated around the x-axis and rotated around the y-axis. So we're rotating these ones around our two different axes. Okay, so what we need to do is just draw a little picture so we get our heads around what's going on here. Okay, so we're going to be like this. Okay, and then we've got, so that's our equation, y equals 4 minus x squared. Okay, then we've got our line here, y equals 3. Okay, and what we're saying is we're looking at this area in here, okay, and rotating it around our axes. Okay. So, thing to realise here is also this is 1 and this is, so this is negative 1, this point here is positive 1. Okay. And up here would be 4. Okay, so we can get working on our equation really. So we're going to be looking at around the x-axis first, so this is rotating this way. Okay, so what we can do is we can set up our equation. Our v equals pi times our integral, okay, from a to b. Okay, well, it's going to be from our minus 1 to 1, okay, of our g of x, our one on top, well, that's our 4 minus x squared squared, minus our equation on the bottom is just 3. So it'll be 3 squared, which is 9, okay, dx. Now, I forgot to clarify this too. In this, they talk about R1 and R2, okay, in terms of the radius of them. Okay, but then they still use the equations anyway. Why they use this idea of R2 and R1 is lost on me because it just seems silly, and that's why I've just stuck with the gx and f of x. So, we'll keep going with this one. Okay, so what we need to do now is we're going to need to expand our brackets. So v equals pi times the integral from negative 1 to 1, okay, of 16 minus 8x squared plus x to the 4 minus 9 dx. So our volume is equal to we can go from pi from -1 to 1 of 7 minus 8x squared plus x to the 4 dx. Now what we can realise here though is that this area, either side of our y-axis is the same. So what we can do then is instead make it 2 pi to take our integral from 0 to 1 of 7 minus 8x squared plus x to the 4 dx. Now you don't have to do that if you don't want, but just to make sure arithmetic a little bit easier later on. Okay, so our volume then becomes 2 pi times, well, we've got 7x minus 8x cubed on 3 plus x to the 5 on 5 from 0 to 1, okay, which means our volume becomes 2 pi times, well, we don't need to worry about our 0, so it'll be 7 minus 8 on 3 plus 1 on 5. So our volume is equal to 136 pi on 15 cubic units. Okay, now that's when we do our revolution around our x-axis. So if we have a look now at our volume around our y-axis, okay, so we can say, well, our v equals pi times our integral from a to b, okay, of x squared dy. Now we actually don't have our two equations here, we don't need to worry, okay, we're just rotating around this way. Okay, so we only have our one equation to worry about. Okay, so for this, our a equals 3 and our b equals 4. Okay, and our x squared, okay, well, that's going to equal y minus 4 when we rearrange our equation we were given. Okay, so our volume is going to equal pi times our integral from 3 to 4, okay, of our y minus 4 squared dy. Okay. So when we do this, we're going to have to expand out our, no, sorry, it's not that, we don't need the square. So we're already squared. Okay, so our volume equals pi times y squared on 2 minus 4y, 3 to 4. Okay. So when we do that, sorry, I just realised I wrote this around the wrong way, sorry, where x squared equals 4 minus y. Sorry, so a negative y and a plus 4. Okay, just need to switch our sign, sorry about that. Okay, so when we put in our terminals, we've got pi outside of our, well, we've got our negative a half times 4 squared plus 4 squared. Okay, take away our negative a half times 3 squared, okay, plus 4 times 3. So our volume equals pi on 2 cubic units. Okay, so we'll keep moving on to our next worked example, which is worked example 9. So this one, we've got find the volume formed when the area bounded by the curve y equals x squared minus 4. The x-axis and the line x equals 3 is rotated around the y-axis and the x-axis. Okay, so this time what we've got, okay, is we draw a little graph. Okay, so this is our equation, our y equals x squared minus 4. Okay, and we're going to 3. Okay, this is minus 4 down here, but we're looking at this area here. Okay, and this point here is our 5. Okay, so we'll start off with around our y-axis. Okay, so what we need to do here is we need to do our v equals pi times our integral, okay, from a to b. Okay, well this is going to be from 0 to 5. Okay, of our g of y, well that's our 3, because it's the one further away from our y-axis. It will be 3 squared, which is 9. Okay, minus. Okay, now when we have a look at this, it needs to be our g of y. Sorry, our f of y. Okay, which is going to be our equation up here. We're going to rearrange it. Okay, so it's going to be our x squared equals our y plus 4. Okay, so that's our y plus 4 here this time. y. Okay, so we're getting there. Okay, so now we can actually take our integral. So our v equals pi. Okay, outside of our. Well, if we expanded this out, we would end up with our with 5 minus y. Okay, so we're going to end up with 5y. Okay, minus y squared on 2, okay, from 0 to 5. So our volume equals pi outside of, well, will be 5 squared minus 5 squared on 2. Okay, because our 0 is going to not actually give us anything, so our volume is going to be pi times 25 on 2, or 25 pi on 2 cubic units. Okay, so we're getting there with this one. Okay, now what we need to do is look at going the other way. Okay, that we're going to rotate it down this way. Okay, so this time, again, we're not going to have a hollow in the middle. Okay, so we don't need to worry about that. So we can simply use our v equals pi times our integral from a to b of y squared dy. Dx. Okay, our a and b, well that's our 2 and our 3 this time. So that's pi times integral from 2 to 3 of y squared. Well, we know what y is. That's x squared minus 4, so that's all going to be squared dx. So our volume is pi times our integral from 2 to 3, okay, of, we'll go expand it out, so it's going to be x to the 4 minus 8x squared plus 16 dx. So v equals pi outside of the x to the 5 on 5 minus 8x cubed on 3 plus 16x. Okay, from 2 to 3. Okay, so our volume is pi times, okay, well we can say it's 1 on 5 times 3 to the 5 minus 8 on 3 times 3 to the 3 plus 16 times 3. Okay, minus 1 on 5 times 2 to the 5 minus 8 on 3, 2 to the 3 plus 16 times 2. Okay, when we work all that out, just do the arithmetic, we end up with 113 pi on 15 cubic units. Okay, so look, that's the end of this video. Again, it's just very similar to our video on the previous section. Okay, it's just this time we have our 2 equations that we need to use instead of 1.